All right, class, we're going to talk about variation. Specifically, we're going to talk about direct variation and inverse variation. So, first I have these grouped together. We will talk about joint variation later and maybe do some application problems, but let's just talk about direct and inverse variation currently. We're going to let some constant k be a non-zero constant real number. This could be a decimal, it could be a whole number, it could be anything as long as it's real and it's not zero. So then these following statements give us the same result, the same connection here. Okay. Oops, there it goes. Y varies directly as x, which would be y equals k times x. So y varies directly as x. So directly as x is saying that there's a k that's going to multiply our x. And that's why we get kx. I'm not sure why that's not showing, but y is directly proportional. Directly proportional to x is another way to say that. And again, same thing, we're saying directly proportional, so we're saying k times x. Y varies inversely as x, so this is k inversely, so k divided by x. And this here, this means multiplication. Here, this means division, right? So y varies inversely as x, so y is equal to k over x, right here. And k is our constant real number, non-zero real number. Y is inversely proportional to x is another way to say that. And it means the same thing. It means we're doing this division. The value of k is called the constant of variation. So that is the constant of variation. Now, sometimes you have to find k, which we will do in applied problems. But for now, let's just start with, can we translate a sentence into the math? So here's some examples. We're going to write variation model using k as our constant of variation, and x varies directly as y. So x equals varies directly ky. Z varies inversely as the cube of x. So this is going to be some k over z varies inversely, so z varies inversely as the cube of x. So the cube of x would be x to the cube. Cube of x here says x cubed. Inversely tells me division. This is where I'm starting from. So this is what it's going to equal something that is inverse to the cube of x, which is our k, our constant. Here again, this is where I start. And directly tells me I'm doing multiplication. T varies directly as w and inversely as q. So this is going to be t equals, and varies directly as w, so that would be kw, capital W, and inversely as q, so that's going to all be over q. Over q. I think I actually put all the answers in here. Let's see. There it is. And there we go. Whether you put K first or W first doesn't matter, because it's multiplication, and 2 times 3 is the same as 3 times 2. So let's try another one. This one is written more in wording. The electrical resistance R of a wire varies directly as its length. So this is some resistance of a wire is equal to some constant of proportionality that varies directly as its length. So that would be a KL. And inversely as the square of its diameter. So inversely the square, so D squared. This piece is the D squared. This piece varies directly, is my K times, and then it says length L, and that's my L. And then inversely tells me that I'm dividing. And I also have that one in there. And then let's see, here's another one. A circle's area, A, varies directly as the square of its radius. So again, A is what I'm starting with. It's equal, so it varies directly. So that is K times the square of its radius. So this piece is R squared. So K times R squared, or K R squared. And there we have it. All right, so there's some examples. I'll do another one for joint variation, but this should help you guys as you guys are working through the homeworks and trying to understand what's happening.